Good morning, everybody. Hi, so before we get started, we have a few announcements. There is a GitHub repo for this tutorial that I encourage you to download during the first half hour of class while I'm speaking. I've noticed the internet's a little slow, so you might want to take turns if you can. If you cannot read the link from the back, it's github.com/nd1, as in Nicole, Donnelly 1, and the repo name is PyCon 2017. And there is also some announcements. First of all, this is fantastic data and where to find them tutorial. So if that's where you're supposed to be, you're in the right place. If not, you might want to find your tutorial. There is a survey link that's available in the Guidebook mobile app, but I will announce it again at the end of the class. It's surveymonkey.com/r/PyCon177. There will be a break at 10:15 in the lobby outside this room. Lunch will be at 12:20 in the Oregon Ballroom upstairs, rooms 201 to 204. At lunch, if you've requested a kosher meal, please let the servers know, and there's also a separate buffet station for vegan, vegetarian, gluten-free, and halal meals. And as much power as we could afford has been placed around the room, so if there's not a power strip in your row, look in front and behind you, and you should be able to find the power. Okay. So as I mentioned, this is fantastic data and where to find them. We're going to go through an introduction to APIs, RSS, and web scraping today. To that end, first of all, I like to get a sense of the skills, general skills of people in the room. So how many people here know Python? Everybody, I hope? Okay. How many people here before have used RSS? APIs? And how many brave people have tried web scraping? Okay. Good. So to that end, also, who are we? So I'm Nicole. This is Will and Tony. We're all here from District Data Labs. District Data Labs is a data science research institute, data product incubator, and open source collaborative based out of Washington, D.C. And we have a group of people that work together on different projects and do things like come here and give talks. So we're kind of there as a community to support one another in our work to become better data scientists. Tony and Will are here to assist today, so if you have any questions, just flag them down while I'm talking, or when we're going through the workshop. So Tony is the founder of District Data Labs. He is also an author, an entrepreneur, and a data scientist. Will, who is here, one of our West Coast members, is also here to help today. He's a developer, security fan, and YouTube aficionado. So when I get to the part about securing your API keys, if you need more information, I strongly suggest talking to Will about that, because right now I just use files on my GitHub. And then I am a recovering consultant. I like to say I worked for about 20 years doing computer forensics and electronic discovery consulting, and recently made a switch over to data science. I am a faculty member at District Data Labs and also at the Georgetown University Certificate Program in the Continuing Education School on data science. And I also like to knit a lot, so I call myself a fiber alchemist. If you have knitting questions or knitting store recommendations, let me know. So here's what we're going to go through today. We're going to start with an introduction to APIs and what they are, where we can find APIs, and how do we access APIs. We are also going to see the kind of data returned by API. After that, we're going to have a hands-on workshop, so there's time set aside for you to go through the Jupyter notebooks that are in the GitHub repo and test things out. There's also a couple of script files in there, so you can try out writing a script to do recursive calls to an API and pull in data. And we're here to answer any questions you have about those when you're working on them. After that, we will go back to a little bit of a lecture format to talk about web scraping. What is it? When should I use it? How do I do it? And also some different Python libraries that support doing web scraping. There is a directory in the GitHub repo on scraping. We're not really going to go into web crawling here. We're not really going to be using Scrapey here, but there is an example of some web scraping we're going to do in the Jupyter notebook. And then after that, oh, it looks like this is not coming up. There we go. After that, Will is going to talk a little bit about Baleen, which is a District Data Labs project that operationalizes data collection from RSS feeds. So we're going to talk about, like, once you have this stuff, how can you make it useful to you? So let's get started. What are APIs? Does anybody want to shout out an answer? You guys can, I know it's 9 o'clock in the morning, it's kind of dreary out, it's the first day, but feel free to raise your hand, get involved, add to what I'm talking about up here. So do I have anybody brave enough to tell us what an API is? Sure, so programmatic way to interact with programs. So it's how an application talks to another application. APIs make it possible to move information between programs as well. They make our data collection lives easier until they don't. One thing we'll run into with APIs out in the wild is they are rate limited. Sometimes there's charges for them. And also, they can limit the data you can get from a site. So a popular thing to do is say, I'm going to do a project to pull Yelp data until you find out that not all the data on Yelp is available through its API, and then you end up scraping things. So where are APIs? Where do we find them? Anyone? Not enough places. Yeah, that's a good answer. I like that one. That is definitely true. Anyone else? Okay. So they're basically everywhere, and not in enough places at the same time. So all these things that we see up here on this slide, Goodreads, Google, Twitter, Facebook, Yelp, Amazon, they all give us APIs to pull data. Copy and paste on your computer is an API. It's not one that we commonly think of as an API because it's not ones that we go and write programs to get data from, but that's how the operating system handles copy and paste operations. When you are out on the internet, you'll often see icons on places to share an article from a website. That's an API. Discus, the comment system a lot of websites use, that's also an API. Oops, sorry. So RSS, what is it? Nobody wants to be very, come on. Somebody must know what RSS is. Yes.
Structured format for revealing the contents of some kind of a feed, such as a blog feed.
Right. So it is XML-based typically, and it distributes web content for feeds. It allows you to have data delivered to your computer or mobile device when it's published. I'm still one of the people lamenting the fact that Google Reader went away. I read tons of blogs through RSS and have an RSS feeder. It's probably one of the things I'm eventually going to write when I start playing around with Django as well to see if I can write myself something. There's different versions of RSS that we'll encounter. They all act mostly the same way. RSS 1 is commonly RDF, Resource Description Framework Site Summary. RSS 2, Real Simple Syndication. It's based on an earlier version of RSS. And Atom is similar to both of the RSS versions, but it's actually a standard, whereas RSS is not really owned by anybody as a formal specification. iTunes. iTunes is an RSS aggregator. I don't know if anybody has ever played around with that and looked at it, but basically people who publish podcasts don't publish their podcasts on iTunes, they send an RSS link to iTunes to aggregate and parse all the data and give you the links to download information. So in talking about RSS, is RSS an API? Yeah, pretty much. I think for our purposes, we can say it is. It's a specific API. It doesn't necessarily work the same way as we commonly think of website APIs to work, in that we are not sending queries and getting back JSON files and parsing through stuff, but it is working with XML. It is a specified semantic structure for calling information to get data. All right, so how do we access these things? And just for context, we're kind of going to keep it limited on RSS and REST APIs with JSON. There will be a little XML in here for people who like to parse XML. But there are different types of APIs, but most commonly we're dealing with REST APIs. So does anybody know what that means if we say it's a REST API? Typically, what we mean is it looks something like this. We have a URL that something knows how to interpret, and it gives us data back. That's not a web page. If we look at different APIs, it looks very similar. Here we have another URL that asks for data, and we get data back that's not in the form of a web page. So basically, using these things is as easy as constructing the URL that the machine on the other end is expecting to see and can understand what you're asking it for. REST was influenced by HTTP, so it tends to look a lot like HTTP. So here we have an example of an API call going to the newsapi.org. It has a path that we're giving the receiving machine and a query at the end of it. So we're looking for a source, whatever source is defined as for this API, and we're giving it some sort information. Basically what that will do is that will go out to the website, which will then digest that information, give you information from its database in a serialized format, and respond. And of course, we can have different responses, just like with HTTP. We can get 200 if things are okay, but we can also get 404 errors and things like that. So we're not going too much into the specifications of HTTP and all of this stuff now, but there are links in here that you can use. And then sometimes our API will require us to add a key. So here we have an API call to DPLA. Does anybody know what DPLA is? Digital Public Library of America. Really fun APIs to play around with there. And here we give it a key and our query, and we get some information back. That is not my actual key, by the way. So how should you store your API keys? So for people who have used APIs before, how do you typically store your API keys? In an email, copy and paste in your code? Do you upload them to GitHub? How many people have uploaded their keys to GitHub by mistake? Oh, come on, I can't be the only person in the room who's accidentally uploaded my API keys to GitHub. All right, nobody is willing to admit it. I'm fine. I'll be alone in that regard right now. So I've given you a couple links that you can grab in these slides to go read a bit about storing API keys. In these tutorials, what you'll see is that I've created a JSON file. I have very smartly added a structure to the name of my JSON file so I can easily exclude it from GitHub in my gitignore file. So take a look at those. So then we go through all this trouble. We build some requests to an API, but what is it giving us on the back end? Anyone? Come on. Did anybody have their coffee this morning and want to engage here? No? Yes, we're getting data. And what forms does the data usually come in? Mm-hmm. JSON, and if it's an unfortunate API, it might be just XML. But yes, we can see here is a couple of API calls to the same API, one in JSON and one in XML, and the data that comes back. So you're getting some serialized structured data back that you can then do whatever you want to do with it. So JSON is a JavaScript object notation, and it's become the more common way for serializing data structures. XML is kind of leftover. It's still there. Some people still use it. Personally, I'm not a fan of it. I don't know. How many people prefer using XML to JSON here? Nobody? Okay. I don't have any XML lovers who are going to write up a bad survey on this class because I just XML, do I? Okay. All right. And then we have libraries in Python that let us easily work with JSON and easily work with XML as well. So at this point, we have some workshop data. So what I have put together for you in this GitHub repo, I don't know if you can see that easily in the back. If you pull down the repo, either clone it or download it. There's instructions here on the README to do both. There is a requirements file if you want to install things that way. And what we have is an RSS folder for the RSS tutorials. Hopefully everybody's been able to get their things downloaded because this internet is running a little slow today. Maybe not. All right, I can show you. Since this isn't going to cooperate with me right now, let's do this. There is an RSS folder, and you will find a Jupyter notebook in there, and also a script file. I recommend starting with the notebook. It's going to walk through a few things on RSS and how to use RSS, and then there is a challenge at the end of the notebook to write a script. And this is a sample script that you could potentially come up with. And then there is the API directory, which is going to have a Jupyter notebook as well. So it's going to walk you through some of the stuff with APIs, walk you through using an API with a key, and then give you a challenge at the end to write a script to do something with an API. And there's a sample solution here as well. So we will work on that until, I guess, for about the next 35, 40 minutes. Will, Tony, and I are available to answer any questions you have, help you get started with the Jupyter notebooks if you're not familiar with them, and things along those lines. So before we break and start working, are there any questions? No? Okay. Oh, wait, here we go. Okay, so how do you start a Jupyter notebook? So you should, first of all, make sure you have Jupyter installed. And then, hold on, let's see if I can get this. Why is my window not going over there? That'll help. All right, let's see. If you have Jupyter installed in your Python of choice, I have, I think, everything running in all the windows. You can just type Jupyter Notebook at the command line. So here I'm using an environment that I have Jupyter installed in, and then it's just Jupyter Notebook to activate the server from that directory. So you'll have that browsing structure like I just showed in the previous window, or you can type Jupyter Notebook and the name of the notebook that you're trying to launch, and it'll just launch that notebook. Okay, so we will come around and help people get started. Okay, so hopefully we have gotten through some of the technical issues people were experiencing. Was everybody able to download the repo in some form or another, either clone or zip? We're all good on that? Walk through the Jupyter notebooks a little bit with some people who haven't used them before, but basically Jupyter is a way I like to present material like this because you can put explanations in there and Markdown and put code in there for people to execute, and they can walk through step by step. So it kind of helps show a thought process too behind programming, which you normally don't get if you're just getting script files thrown at you. So does anybody have any questions from that portion? Did everybody at least get through the RSS notebook and download the RSS data? No, I see some shaking heads. Were there questions about it? Just technical difficulties? All right. Well, we'll be here on the break and afterwards too. If you want some help, I can sit down and try to help you go through some of that stuff to get things running. For people who did the notebooks, how did you find them? Was the information, did it work correctly? You got an error where you're supposed to get an error and no errors in the other things? I do put things in there to give you errors, so if you see an error, don't necessarily panic. Read what's below it and see if it was supposed to happen. Okay, so this morning we so far have gone through APIs to get access to data, including using RSS as an API. We've gone through the serialized data that gets returned, so you'll see in those notebooks that there's some JSON that comes back that we parse through into pandas to make a data frame out of. And we've talked about where you can find APIs. A question came up earlier. Somebody was asking me where they could find RSS feeds. If you Google the name of the web, or if you go to a website and you want to see if they have an RSS feed, just try adding a /RSS at the end of the URL. That sometimes works, sometimes it doesn't. Search their page for the word RSS, or just Google the website name in RSS and see if a feed comes up. And then there's also RSS directories out there, so you can Google for an RSS directory and people kind of accumulate links, like a white pages for RSS, essentially. All right. Okay, so web scraping. How many people, there were a couple people here who have tried web scraping before. Who's tried it? How has it gone for you? Yeah? Yeah, hit or miss. That's a good one. So what is it? Does anybody want to throw a definition out there of what web scraping is?
Utilizing basic functions to just load the web page and extract the data directly from the web page.
Yes, so we are loading a web page and pulling the data out of it instead of using an application type way. So web scraping can be called different things: screen scraping, web data extraction, web harvesting. You directly access a page and you copy its data when an API to do so for where that data is not available. And it will give you a way to somewhat automate the process, copy the data, save it locally. There is also web crawling, which is somewhat different. Does anybody want to define what web crawling might be versus web scraping? So in web crawling, what we're doing is we are gathering the website's links and kind of traversing them to establish the network. And a lot of times web crawling and web scraping are used in conjunction with one another. So you start at a page, you scrape the data, you go to the next page through a link and scrape that data. So scraping is done explicitly to extract specific information by a page, where crawling is done in order to obtain information about the networks within and between sites. Web scraping also is a lot of other things that might not be as good. It can be a violation of terms of service of a website. How many people actually read the terms of service on a website they go to? When you're scraping, you probably should. It can have legal repercussions. I think there's a case out of Stanford, and I forgot to pull up the information about it, where they have a lawsuit involved with some scraping that was done. When it's not a violation of the terms of service or illegal, it can still be considered ethically ambiguous. So what if you have a website out there that's kind of small, they don't have an API going on, they don't forbid you from scraping it, but by scraping it, you overwhelm their resources and take them down? It's basically a denial of service attack. So that can be ambiguous. And then it it's a customized process. You need to customize it for each site. You can't just come up with some framework that's going to work on every site, because as much as we like to think the web is nice and pretty, when you start looking at the guts of it, it's really kind of ugly sometimes, and people don't do things the way you expect them to. So when should you web scrape? Should you web scrape? Does anybody have a when they should web scrape answer? There's no API, and you really, really want the data, and they won't give it to you. Basically, I'm going to crib some slides from David Eads, who's probably one of my favorite web scrapers. He's a person, not an actual scraper. But he said in a PyData DC presentation he did last October, if you need a scraper, you have a data problem. There is a link in these slides. The useful scraping techniques link up there is a blog post. David currently works for NPR, but announced on Monday he's going to ProPublica. He works on scraping data for their reports, and he did this amazing web scraper to pull data out of an arms listing website. So he basically scraped all their information for a story some of the reporters were working on and wrote up this great blog post that was kind of mind-blowing for web scraping. He does a lot of he does object-oriented programming and parallelization, and got into the same Amazon Web Center that the site was on, so did a ridiculous amount of scraping in under a half hour for a really cheap amount of money. I highly encourage you to take a look at that. So basically, I'm borrowing some of the slides that he did with his permission, but one of the things David points out is fundamentally a scraper means something isn't right in the world. There's a database out there, it's powering a website, but you only have access to the website. You don't have access to the underlying data. But the good data, well, if it was easy to get, it probably wouldn't be good shit. So there you go. So we have to decide, basically, if it's good enough to put all this effort into. But his advice on scraping is never scrape unless you have no other way of liberating the data. Budget appropriately. That means not only money budgeting, but resource budgeting. Is it really worth all that time to go get the data? Consider the ethical ramifications. So if you Google web scraping ethics, you'll find a lot of information out there with people going back and forth. Read the terms of service and do your legal research. If you're going to violate somebody's terms of service, you really should know you're doing it, and decide if that's really the path you want to go down to. And if you are doing it from a business perspective, talk to a lawyer if you can. So anytime the data journalists at NPR do web scraping, their legal team is involved and aware of the situation and reviewing terms of service and things like that. If you can, if you have time and the data's good and you want to get it, try a FOIA. There's also a lot of information out there about FOIA in data. So a lot of cities are now going to open data standards but don't necessarily have all the data you want in an open format. You can try FOIA-ing them. I work for a city, I work for the city of DC, and I have scraped their data. But there's also FOIA mechanisms for getting some of the data. So even though DC is kind of being lauded right now for one of the cities being progressive enough to go to open data, not everything's out there. We recently had a mayor's order, actually, that is going to require us to inventory all the data, and for things that are released under a FOIA without any redaction, we're going to start making them open data sets. But we have to get all our agencies on board still. We still have some agencies that use third parties to host their data, so we have problems getting to that. Question? Yeah.
I have a question about these open data sets from city and county governments. Are they being able to be used for commercial, applications and products?
Okay, so the question was, is the data that cities and counties making available to be used commercially? And that depends on the city. DC is not selling its data, so it's not limiting what can be done with it. We've kind of been open in the fact that we're putting out a GitHub repo with all this kind of stuff and asking people to contribute in that regard. So just check the terms of the city. There should be a terms of service on these open data sets that let you know what you can and can't use them for. Yes? In DC and a few other places, we're using a service offered by Esri, who does the GIS software. So they have basically a platform cities are building off of. But yeah, But so I will admit, I have scraped data when it's not available. I have scraped it from the city I now work for. It was before I was an employee. And it's actually one of the things they were asking me about in my interview. They're like, but how did you get that data? We can't get it out there and open. Like, well, scraped it. A lot of times, Department of Health records are a really big thing now with some data science data sets. So restaurant inspections, a lot of cities use a company out there to host them. They're all kind of on the same platform, and there's no public-facing API for it. There used to be, but they took it down. So if you don't get the health department to answer your calls, sometimes you just need to go do that. So here, I don't always scrape data, but when I do, I get IP addresses blocked. My first scraper totally got my IP address blocked, but it was 2 days afterwards, so they weren't doing it real time. They looked and they're like, what the hell is this? Blocked. Try not to get blocked. Yeah, so basically I crawled the entire network trying to scrape it, and when that didn't work because it was too slow, I used Selenium to download all the pages locally and then scrape them locally. So it was after I did all the downloads of their pages with Selenium that I got blocked. Right. Mm-hmm. So the question is, if you create a scraper that goes through and scrapes web pages for published prices on a catalog, is that kind of it depends on the term of service of the website. So you have to look to see what they're saying about their data. Correct, yes. You should go into all the websites you are scraping and read their terms of service when you're doing something like that. I don't know that everybody does. We all have our little dirty Python programming secrets in the closet, so. I'm telling you, you should. I'm not the web scraping police. I'm not going to come over and make sure you are, so. So you will see in the scraping repository, that's essentially what I've done. I've created a repository for you that creates a web scraper that goes out and scrapes prices off of a website. I did read the robots file. I don't remember if I went through the whole terms of service file, but we'll see. So that brings us to the question of how do we web scrape? And this is one of the things, though, we all know Python. We all learned Python differently. You learn how to do something and you kind of do it that way and not necessarily other ways that might be easier. So it all depends on how you learn, what somebody showed you first, what tutorial you found on the website that made it easy for you to understand. So we have Python libraries that will let us scrape, but we also need to take a look more from a perspective of the big how, not the mechanical how. We need to look at the robots file. Does anybody know what a robots file is? Yes.
Robots.txt is a standard file that websites can put to say how they want to be called.
Right. So it's a standard file that people put on websites to tell you how to crawl them or not to crawl them or what parts of them you can and can't crawl. So a lot of times you can kind of see maybe they have data you don't want them to find if you look at their robots file. But there is, it's basically a text file on the site. There is no programmatic enforcement of how you do it other than they can maybe block you from doing it at some point or block your IP site. But it is a text format where you will see a user agent at the top and disallow. So it's telling you where not to go and what agent shouldn't go there. So a user agent star means everything. Anything that's going to come look through this website, you cannot go to these folders on our site. And there's a link to about robots.txt. They can get pretty convoluted. But this about robots.txt will explain some of the things that you commonly see in them. All right, so after we do that, we need to approach the how are we going to do it. So Scrappy or Scrapey, I don't know what the correct pronunciation is a common library or it's a framework used to scrape websites. It relies on things that we are going to go through manually using things like urllib and requests and beautifulsoup. So these are some of the common Python packages that will help us with this task. And then two, you'll see libraries like urllib is part of Python, but it didn't do everything everyone wanted it to do for doing things like that. So somebody wrote a new library called requests, and I kind of use them interchangeably in the tutorials. So we also have Scrappy, which we're not going to go into, but there is a folder in your GitHub repo that shows essentially the same scraping done in the notebook, in the IPython notebook, done with scraping. And then Nutch is also another library that can be used for crawling in software. It works off of Hadoop if you use Nutch 1, and then they're building a new one called Nutch 2, which works off of Apache Gora. I'm not going to go into those in this site at all, but it's more of a framework to work with NoSQL storage and doing a lot of scraping and crawling. Okay. When you are scraping, you should expect a fair bit of trial and error. It does require you sitting there and reading through the source of web pages. It's not something, I struggled with like even how to start teaching people to do this. So the tutorial we have will walk through some basic scraping, and then there is another notebook to show you my thought process on scraping, because when I was sitting at home last week going, damn, what am I going to do to teach this? I got an email from my favorite liquor distributor, and I was like, oh, I wonder if I can scrape their page. So I did. I scraped their Scotch prices for you. And that notebook will go through kind of how I approached doing that and what I did to do it. So this is our summary for afterwards. Are there any questions on this part? Yes. Basically, it's usually at the top level of the website. So if we go to, here we go. So Drink Up New York is in our second notebook for the scraping tutorial. And just off the top of the site, if you do a /robots.txt, here's the robots.txt file. Yes. Yeah, and your if you use something like Scrapy, it will, or Scrappy, it will look for that. And I think you can set up things in there to not crawl things that you're not supposed to crawl. So if I wrote a scraper with Scrapy, and it went and saw that I was scraping a path that was in the robots.txt, and I had the setting set that it should follow what the robots.txt file says, it wouldn't do it. So, but yeah, it's just a text file, so it's not like it's a website police force there to stop you. So in our GitHub repo, we have a scraping folder. Start with scraping notebook, and that will go through some of the basics. Scotch.ipy notebook is the scraper that I put together last week when I was thinking about how to kind of share a thought process behind scraping. And then if you get through all of that, or your burning desires to learn Scrapy, sorry, not teaching it, but here's a scraper built with Scrapy that you can go through. I really do recommend going to their website. Their Read the Docs page, they have a tutorial you can walk through. That's really good. That's basically how I learned to use it. So it is now 10:15, so we do have a break at this point, 15, 20 minutes, whatever you want to do, then come back and start working on these notebooks. And we will work on that for about an hour-ish and answer any questions. And if you did not get through the initial part and you want us to help you with that, please come find one of us and we'll get you up and running. Okay, so given internet slowness and some Python environment compatibility issues, what we're going to do is change up the programming a bit, and we will go through these notebooks together and discuss kind of what they're doing and how the code is working. I encourage people, I might call on people, or at least ask for volunteers to read code. When I teach workshops at Georgetown, that's the way I like to do it, because I think it helps kind of, if you can articulate what the code is doing when you're reading it, it helps you understand what's going on a little bit better. So some people had not worked with Jupyter notebooks before. I find them really good for teaching things like this because you can add annotations and text and things like that and talk about what's happening. So the basic notebook structure is there's these cells here. We have different things we can put in them. I'm using Markdown and code and everything for these cells, and we'll just kind of run through it. You can hit the play button here to go through a slide, or you can hit Shift-Enter. So let's start with the RSS notebook. We'll go through this one. This is fairly short. I've given you some links to different RSS content that's out there on the web that you might want to play with. One of the neat things that I like is my public library in DC will let you RSS your catalog searches. So you can do a search for Python and then put this in your RSS reader, and every time they get a new book that matches it, it updates in your RSS reader. See if we can get to this. I've been having problems with their website on Chrome. So this is basically what it's pulling in. This is an RSS of all the books in my DC public library that match the subject Python. All right, so we are going to be working with the Netflix Top 100 DVDs RSS feed in this notebook. I haven't found any Netflix feeds on streaming. That might all be done through APIs, but we'll see if we'll pull the site up. They do a top 100 list of their DVD rentals and update it every 2 weeks, I believe. And we're going to use feedparser to work with it, and we're going to pull the data into a pandas data frame. All right, we'll stop waiting for that to load. So as with anything when we're doing Python, we need to import the libraries that we want to work with first. So as I mentioned, we're going to do feedparser and pandas. In the next cell, do people want to do like speak out loud programming, or do you want me to walk through them all? So if nobody wants to answer, I won't sit around and make you answer. All right, well, we'll just walk through it this way then. So starting out, creating a variable called RSS URL, and it's basically the URL of the Netflix feed. And we are going to give that to feedparser and create another variable. Basically, our feedparser parse response is going to become the variable feed. And parse is one of the primary functions available to you in feedparser. And what it ends up looking like, what it returns is a feedparser dictionary, but what it really is pretty much the same as a Python dictionary. So we can access it the same way. For example, we can look at the keys that it has, just using the standard dictionary.keys function. And here we can see that we have headers, entries, feed, namespace, version, status, encoding, href, and bozo. I like bozo. I like clown. I'm not one of those people afraid of clowns, so when I saw bozo when I first did this, I'm like, what the heck is bozo? If we look at it, it's an integer. Okay, that's interesting. I don't know what it is yet, but we'll get to that part. And then feed is another dictionary within our dictionary. So nested dictionaries. There is links throughout the notebook to key areas of the documentation, so I encourage you to RTFM. There is actually, the feedparser documentation is actually written fairly well, so it's not one of those that's difficult to get through, but internet issues still. All right. Maybe I will try the other network to see if that works any better for getting some of these things to come up as we go through them. All right. So we're going to look at some of the data in the feed. The documentation will more fully explain things that we're not going through here. So if we look at feed.version, it tells us what kind of feed we're dealing with. Here we have an RSS2 feed. As you mentioned earlier, RSS is not a specification owned by anybody, so there are kind of variances into how RSS2 will be implemented. So bozo, I found out after digging into this, is a key that's going to look through our feed and tell us whether or not it's well-formed. And what it means by that is it's just basically testing what it thinks the specification should look like and see if the data comes back that way. If it's not well-formed, feedparser will still parse it, or at least attempt to parse it, but you might get errors along the way. So if you're doing something where you want to operationalize pulling in RSS, bozo might be an interesting key to use just for error handling purposes. So here we're looking to see what our feed's bozo key is set in, and here we can see we have a well-formed feed. So we know bozo is 0. If it was 1, it would have said potential trouble ahead. All right. So then our feed portion of feed up here, we said was another dictionary. So let's look at the keys that it has. And here we can see a little more information. So we have language, subtitle, links, and we can just address those and print those out. So we can see the RSS feed is titled Netflix Top 100. It has the link to the dvd.netflix.com page, and it has a little description. So if you go through the reference section of feedparser, it will show you an annotated example of what it expects to see in an RSS2 feed, and it will look based on elements. So basically, if an element that should exist isn't there, it might give you an error if you try to address it. So here is one of those deliberate errors I like to put in things. Feed.feed.published. Publish is a standard part of an RSS2 feed. Netflix is not using it, so we get an error. But since we are using a dictionary, we can use get to see. So if you want to write code around this, you can start using some of these functions that we have in Python dictionaries to error handle things like this. So if your published is something you want to pull out, if it exists, you know how to look for it. So the data we're looking for is actually is in the entries. So this is a top 100 list. We expect 100 entries, and we can see here we have 100 entries. And then feed.entries, which has our data, is a list. So if we know how to handle lists on Python, we can start working with those. So you can see here, if we look at the title of the first entry in the list, we get a name. And then we can do some code to pull out the names of all the titles in our entry. So that is basically Netflix top 100 list right there. So you can also easily pull it into a data frame. And this will put using pandas. So you have the ability to convert a list in pandas to a data frame, and that's all that code did there. So what I did then at the bottom is, before we go to the next part, does anybody have any questions on that? On what was done there and the different elements of feedparser and where to get more information if you need it? Okay. So I have given you a challenge here to create a data frame of the top 10 movies from Netflix Top 100 and iTunes. So if you were interested, if you're a movie geek and you wanted to keep track of what people were watching, you could set up a script to go out and pull this information and create your own top 10 lists. So there is a link here to a sample code. I think I will pull that up in Atom instead, so it's a little easier for us to read through. Okay. All right. And if you want to send me code critiques, feel free. I've been working in Python for a little while, but it's not my first, second, third, or fourth programming language, so it might not be Pythonically correct or the most efficient thing or the only way it's definitely not the only way to do it. There's so many ways to do things in Python. So this is basically a script file that I wrote as part of that challenge. So this is one way you could do this. We're going to take the top 10 movies from various feeds and compile them as a data frame. So we are going to use the feed parser library, OS, library pandas, and date time. I have set up some global variables up top for my feeds, so I only need to change them in one place if I want to change what I'm doing. And I have set up some data frame columns as global variables because I'm going to use those in multiple places as well. Yes? Okay. So the question is about data type encodings, UTF, ASCII, and are they handled by feed parser? And I believe feed parser handles that fairly graciously. I have not encountered errors with that. I'm not sure what it's doing on the, oh, we have somebody up here saying no, it doesn't. Really?
If you run it, one of the iTunes contains a quote.
Oh.
The actual quotes, and so so what I had to do is I had to actually modify the code a little bit. There's an encode function, so I just took the entire data, ran it through a UTF-8 encoder, and hooked up with the CSV file.
Okay, so the point raised up here was there was an error with my code running on the iTunes feed. There was not when I ran it, so the list has changed, and there's new things up there. But yes, my code up here does not do any type of encoding error handling at this point. That probably could be a whole 3-hour tutorial all on its own, and it's not issues that I've built into going into this. There's a lot of resources out there online for handling encoding, but you'll find when you Google it, it's a problem a lot of people are running into. So, does that answer your question, at least? Okay. Okay, so if we go down to the bottom of our script file, I have set up things down here. So we're going to set up a data frame called top 10 data frame, and then we're going to go through each item in our list and run it through this function, top 10 movies. And then at the end, the data frame gets returned to us down here, and there's code here to write it out as a CSV file. So if we go up to the main function here, all that I've set this up to do is take the RSS link and the data frame as arguments coming in, and then we're going to go through and run the RSS link through feed parser like we did in the notebook. It's going to give you a little feedback here to see if it's a well-formed feed or not. And then also, too, in my data frame, I decided I wanted to put the date there. And what I've told the code to do is if published does not exist in our feed, use the current date as our date, so the date we run the code. Because that would make sense that the feed was published on the day that we're reading it, or it existed at least on that day. And then we have a little while loop here that is going to go through and append the information to our data frame. So I guess we can try to run it now and see what error is coming up. Let's see. Get to the right place on my computer, and I will show you. Uh-huh.
The parser will handle the encoding just fine, but you can't output the CSV.
Oh, it's the CSV that's failing because of, okay. Well, let's, So you can see there now it's running the iTunes. It ran our iTunes RSL. It checked the bozo. It checked the bozo on our Netflix as it did each one. And then, oh, we got a CSV here, so let's see what happens. What error were you seeing when you output the CSV? Okay. Okay. While you're doing that, I did not actually write this for a live demo, but if we want to see what the code is doing, let's see if we can just throw a print statement in here, and we'll rerun the code and get some output on our screen to make it a little more exciting. Okay. So what I just did there was I threw a print statement in my while loop so you could see what the code is doing. So here we go. It gets the iTunes feed into the function. It checks the bozo. It prints our statement based on the bozo value. And then it is going through and parsing the first 10 items. And these are the items that we're writing or are appending to our data frame. So we can see we have a source, what the feed is, the date, it's today's date. I don't believe either of those RSS feeds are using the published date, so it's the date for today. It's the rank, which is basically what number is it in our loop as we encounter it, the title of the movie, the link to the movie, and the summary information that's given in that feed in the feed entries. So it goes through the first 10 in iTunes. It goes back to the main part. It gets our next URL, which is the Netflix Top 100. We can see here, we check the bozo, and then it goes through and appends those items to the data frame. So then at the end, what that function does is it returns the data frame to the value top 10 data frame, and then it creates a CSV from the information. This is also written that if the CSV exists, it's going to append onto it. So if we ran this one more time, we would see another top 10 from each of those things in our feed with today's date on it. All right. So that, check the time. Does anybody have any questions on that? If you feel like sending me a code critique, please do it in email instead. All right. Well, are you getting that data as an RSS feed? This is strictly for using RSS feeds. So this is how, I think it might do some other thing. It does add them, but yeah, that's essentially what the library was created for. If you were using an RSS feed, here's how we can parse through some of the data. Yes? Okay, so the question was, can we explain the well-formed feed? That's feedparser doing it, and it's basically looking at the feed specifications. So in the notebook, there was a link to the feed specifications on what a feed should look like. It's checking to see if it looks like that. And if it doesn't, if something's out of place or put in the wrong place, it will still try to go through everything, but it could error out. All right. Any more RSS questions? And then after we go through these notebooks, Will is going to talk about RSS a little more and operationalizing some RSS collection. So he can also answer questions at that point too, probably. So are there any more RSS questions? Okay, let's move on to the API notebook. Okay, so this is just another Jupyter notebook for you to go through. I won't read to you all the information that's there. You can go through that later. So we're going to start out using urllib to get our information. This is where we're going to, this one might actually work, I think, on 2.7, okay, because I used urllib and not the updated version. So what we are going to do is we are requesting this URL here, the OMDB API. So OMDB is a movie information API that's community supported out there. I'm not a particularly a big movie geek. It's just easy to find these APIs and RSS information for this kind of stuff, and it's something relatable to a lot of people and non-controversial. So it seems like a fun example to use. So urllib is going to request this URL, which is our API URL. And let's see if we can get the OMDB API page to come up. We might wait for this one to load. Okay. Interesting. They're going to become private soon. All right, so if you come to the OMDB API page, they show you how to use the API. So how to construct the URL requests, the different parameters you can use, and that is where this API URL request came from. So we're looking at omdb.com, we're looking for the title Game of Thrones Season 1, and we're reading that information. And here we are decoding it as UTF-8 to handle any type of encoding issues. So we're going to get that information back as a variable called data. And then does anybody want to guess what the type for data will be based on this information? Dictionary. So there you go. So then we can look at what our data looks like. So if we look at the keys, we have the keys response, total seasons, title, episodes, and season. If we look at the whole thing, we can see a very nicely set up dictionary. So we are getting the data basically and loading it using the JSON library. So we have something we can easily parse through. We can go through and print out our titles and the ranking, or the IMDb rating. So it gives us rating information in our dictionary. We can see an entry here. We have episode number, the release date, information from IMDb, so what its ID number is on IMDb and what its rating is on IMDb. And then we're using that to print that information out. So then we can also pull this into a data frame pretty easily. So here you go. This is all the information in our object that was returned. And we can save it to use later if we want. So that's just basic usage of APIs. Yes? So the question was there any reason why I used urllib instead of request? No, no good reason. I don't have a particular love-hate of either of those libraries, so kind of use them interchangeably. Requests is a bit more robust than urllib. Yeah, that could be. I think I learned them both about the same time, so I go back and forth between the two. Okay, so that's basic API usage. Sometimes you need a key to use an API. And we're going to use the Digital Public Library of America API for this example because it does require keys. The keys are easy to get, and they have a lot of good data in there. So you can take a look at their API here, and there's information on how you request a key. So the notebook is set up to help you request a key. You basically request it, you can do a command line request to get a key and it'll send it to your email. So when you get to this part, if you're playing around with it later, if you are on OS X or Linux, you basically want to uncomment this and use the curl command here, and you fill in your email address right here. On Windows 7 or 10, I believe I know it works in PowerShell. I've done it in PowerShell. I'm not sure it'll work on the other command lines. But, whoops. You copy this command. You put your email address here in the URL where you're requesting the API key, and this command will basically send out your request to DPLA, and they'll email you a key to the email address that you provide in that link and that URL. And you should see some kind of request come back here, or some information come back here. More or less, you're looking for API created and sent via email. So if you don't see it, check your spam. So, like I mentioned earlier, and nobody wanted to join me in that I've published my API keys to GitHub club. Last chance, it's a great club. There's a lot of us here. All right, I got Alan raising his hand in the back now. What I've done here to store the API keys is I've created a dictionary and saved it as a JSON file. In your repo, I'm not gonna, this is my key. I don't think anybody's gonna be able to copy that down, but that's not in your GitHub repo, but this config secret template.json file is. So you can set up basically something like this to store your API keys. Yes?
What's the risk of having someone know your key? I guess they could just illegally find your data or something, you can be liable?
Right, so the question is, what's the risk of having someone know your key? If it's a service that requires payment, or if it's a rate-limited API, they could use all your stuff. It's not the end of the world unless it's an API that's charging you money, I would say. But best practice is not to let it. A lot of sites will track what kind of information you pull and how much information you pull and things like that. So it's also good for them to see if other people are using the API. I think there's a story I've heard third hand about people publishing their code with the API keys, and if you're using something like Amazon Web Services, somebody can then take your keys and start launching all these machines and cost you a lot of money in very little time. So, okay, so yeah, we had somebody up here saying it happens a lot with Amazon. Yes. I'm sorry, can you repeat that? Okay, so the question is the key short-lived in its duration? I think it depends on the service. Some places you might need to get your keys reissued more often than others. I know a lot of services also have it set up that if you accidentally publish your keys, they make it easier for you to request a new one. So yeah, it would just depend on the API you're using. Correct, you would request a new key and update. Yes. Mm-hmm. Okay, I'll summarize that a bit for everybody that didn't hear it. So it's basically your credentials for a website. So the security risk of publishing them depends on the security of the data, but as was pointed out, APIs are not only for retrieving data, you can use APIs to push data. So if your key is not a read-only key and somebody gets their hands on it, they can start adding data maliciously or not maliciously to your data set. That might not be what you want. Okay, so if we come back here, this is going to read, oh, I changed my name. I had changed my name after writing this of my file to make it a little easier in my git ignore on what I was ignoring and not ignoring. But basically, so what I just did was I read the key out of the file here, and here is my API key. When you run it, it won't do that unless you've set your API key up. Okay, so this time we're going to use requests. Since I have no particular preference for urllib or requests, we're using them both. And we are going to import that, and we are going to start constructing a URL and parameters with variables so we can pass them with requests. So I'm setting up a URL, which is api.dp.la v2 items. Does anybody know where that base URL is coming from? Basically, you want to look at the API specifications because they should be telling you what that should be. So basically, we have an API URL, and then we have parameters. And requests let us set our parameters up as a dictionary. So if we look at these different parameters, the key name, API key, and queue are specified by our API. So those are the parameters it's going to look for when it sees the URL to know what you want from it. And in this case, we are passing the API key into it, and the queue is the query on DPLA, and we are going to look for goats and cats, because those are two things that are fun. Because we all know cats power the internet, and I personally think goats are the perfect animals because they're entertaining, they give us milk, they give us fiber for knitting, and then when they're jerks, you make a nice curry out of them. If you're a vegetarian, I'm sorry, but I do like a good goat curry. So here we go. We have set up just 2 variables with this set of code. And then here, we're going to set up another variable called R, which is using get from requests. And this is basically how we tell requests what we want to use. We have a URL and our parameters, and it's going to construct us a URL and get that information. So it just ran that. It gave us back a response, but the response also has different things that we can look at. So if we want to see the actual URL that we created with requests, we can print that out. That is very useful for troubleshooting when you're first starting out with these kinds of things, because you want to make sure you're sending the URL that you think you're using, and that's just the quick way of doing it. And then we can also check the status code that we got back. As we saw earlier in the slides, we have the same kind of status codes we're dealing with HTTP. Our request gave us a status code 200, so what does that mean? Everything's good. We're good to go. If it was a 404, we would know that it didn't get our data. So here's another link for status codes in here if you need them. And then we can take a look at our content. So this is what requests went and pulled for us. And we can see we have a dictionary again. We have some information up here that's part of our return. So we have a count 40. Does anybody want to guess what that means? It's probably our query returned 40 items. It starts at item 0. Limit is one to watch out with. Sometimes you are limited on how many things you can get back on an API call. Right now we're using a default of 10. So this dictionary will have the first 10 items from that API. Let me get rid of that. The 40 was the total number of items that the API could return for that query. Right, we started at 0 and we're limiting at 10, so it just returned the first 10. But we will take a look at this. So the 10 is a default with DPLA. Oh, so since the last time I have run this, they have added more goats and cats to the DPLA library. That's exciting. So you can see here when I initially created it, it pulled back 29 results. There were 29 total. Now we have 40. DPLA actually has a parameter to let you change how many things you get back, and we can get a maximum of 500 at a time. So we can just set our page size parameter, which is how many results do we want to be 500, so we get everything that they have currently at this time. I'm waiting for the day that it goes over 500. So if we run that again, we will get another dictionary back that's going to have more items. So you can see here we still have 40 items. We started at 0 and we're limiting it to 500, which means we get first 500, but in our case we would be getting 40 because there's only 40. Okay, so at that point you can start writing loops to pull data out. So what I've given you is an example script that I have used before to pull information from the SeeClickFix API. SeeClickFix is a community-oriented website that integrates with 311 systems in cities, so you can put in service requests and things like that. There's links here to their API, and here's their description. They allow you to play an integral role in public services, routing neighborhood concerns like potholes and light outages to the right official with the right information. interesting fact, one of the things that city residents are most concerned about are rats. Like, more than like, how good is my 911 service? They're more likely to encounter a rat than call 911. So that's, C-click fix came out of those concerns. And then I have provided you a script file that we'll take a look at and discuss. So does anybody have a question on APIs up till this point? Yes. I'm sorry, can you repeat that? Yes. So that part, so the question was, what was the difference between key equals and Q and the different things we put in the URL request parameters? What those items were actually dictated by our API. So if we look at that part again, if we look at this, hold on, let me stop scrolling through that. So this params variable, the dictionary constructed, API key is an actual keyword that the DPLA API is looking for. So that's what that is. So the differences between API key and Q is just they're different parameters in the URL DPLA is expecting you to send them. Does that answer your question? Yes. Yes. Oh, so, all right, if you were going to construct the URL yourself, you would need to basically write it out with Q equals goats and cats. Requests understands what this is and what it's trying to construct, so that allows us to do it that way. Yes. So the question is there any difference between using requests to pass the parameters and constructing it ourselves? And the answer is no. So this URL that request gives us is the same URL that we would construct manually. So it's just trying to help out and make things easier to track. So if we put that URL in, we can go exactly to the results page that DPLA would give us. Okay. Are there any other questions on that? Okay. Yeah, so request is handy for if you want to programmatically do things like that and maybe pass different parameters. You have like 10 searches you want to do at a time. You can run through like that. Okay, so here we have a script file that's going to use the C-click fix API. What it does, let's see if we go down here. We're just running that function so that everything is here in this function. And what I have done is created a function that lets me loop through multiple pages depending on how many pages the C-click fix API says exists for my search. So I have set up a whole bunch of parameters here. I have created defaults for them in case they're not passed. So the first time this runs, it's going to use everything in the default. And if we go down, when we go down in the code, we'll see depending on how many pages we need, it will call the function again, will call itself recursively, and will change some of the parameters it's using. C-click fix has a base URL defined for their API, which is right here. We are using requests this time. We are getting the base URL with params, the search parameters. So up here we have defined search parameters to be place URL. So that's where I am pulling things from the C-click fix API, and the value I have is District of Columbia. I also have a parameter called after, which is the date field that it takes in that it's looking for. And here you can see our date is October 1st, 2016. So we're going to pull everything after October 1st, 2016. And our per page maximum with C-click fix is 100, which, depending on how busy a city is, can be not even a portion of the day, like a small portion of the day. So requests here is going to construct a URL for me that is made up of this base URL, and then these parameters. So we're starting at page 1. This pulled count, page and pulled are counting parameters that we're going to use in the function. So it's going to use base URL and the search parameters to create a URL to pull data from see-click-fix. So here we have a little error checking going on. It is looking to make sure we get a reply of 200 for our status. And if that happens, it's going to load the response data into a dictionary from our content. It's going to look at the count all function that gets returned with that data. And it's going to increase our pulled variable by 100. So we know we have a maximum of 100 per page. We're starting out with 0, so the first time we pull it, it will be 100. And then what this is going to do is write the file and check to see if we've pulled all the data. And if it hasn't pulled all the data, it's going to update the parameters and call the function again. And here, each time it updates the parameters, it's going to print them all so you can keep kind of track of what's going on. Otherwise, you're looking at a blank screen for a while. And then if our response is not okay, it's going to tell us what the status is. So let's go through that real quick. Let's run that before we go through some questions. Where did my... Okay, so what this is going to do is use those parameters I set up in the function. So it's doing Washington, D.C. requests, 100 per page after October 16th. And it'll take a minute, I think, with this internet. We won't let it run through the whole thing because I think I do have some sample output I can show you. So here we go. So it got to the point now where it printed my parameters, which means it pulled the first page, and then here it's showing me from my print function what parameters it's passing to the function again. So this time when requests goes through, instead of page being 1, it'll be page 2. Basically, we're updating the page parameter. We're keeping count of how many things it told us we had to make sure we're getting through enough pages and pulling each of those pages. So I am going to stop that there so we don't sit here and watch it all day. And we can take a look now. I had it write the data out to JSON files. So I'm pulling all my data from an API and saving it to my disk so then I can do something with it. You could also just start doing something with it right away. You don't have to save it first. But if you're doing kind of data science type things, it's always good to have your original data that you can go back to in case you need it for something. So here is the response information that see-click-fix gives us. It tells us we're getting 100 things per page. We are on page 1. We have 2,635 entries. Well, we're not going to get all those on our first call because it'll only let us get 100 at a time. So these are the things that we're looking for here. So it also keeps track of the previous page, the next page, and tells you what those are, and basically how many pages you have of results. So that is the information the function was looking for to decide how long to keep going. So if we go back to that function, that's the wrong file. Okay, here we go. So we started out with these parameters. It printed out the parameters it sent on each subsequent call. But here we look count all. So our data variable is our response. And then in that response, we are looking for the pagination entries. So entries is here. And basically, we got to it by going to metadata pagination entries. So that's all the script is looking for. It wants to know how many things are there that I should be pulling. Pulled is pulled plus 100. So pulled is, we start out with 0, and each time we pull more data, it increments by 100. And then it's going to look to see if pulled is less than count all. So the first time we pull 100, and we know we have 2,635, so the first time pulled will be less than count all. And it will basically pull pages of 100 until it's pulled all of the data. So that's how you can kind of write a script to go through and pull multiple data sources. So does anybody have a question on that? C-click-fix doesn't use API keys. It might exist in your city, so you can go play around with this and change the location, change the dates, and see what kind of data you can pull back. Okay. So the question is, if you want to use multiple connections, I think you just need to set up your script file to do that. I don't think you'd be restricted. It would depend on the API on how many requests you can do. So if it's something that requires an API key and you can only get a certain number of requests at a time, you might run into problems. But if you parallelize your processes, I don't see why you wouldn't be able to do that. Okay. All right, and then we're going to take about 10 more minutes to go through the scraping information. So in the scraping folder on the repository, scraping notebook is going to go through some of our initial scraping information. So here you'll see I'm going to start off using urllib again. And we are basically going to use urllib to pull down a web page and parse some information out of it. So I am using xkcd here because that's also one of my favorite things, and they're very good for demoing stuff. They're not as good for demoing the RSS stuff because I think they limit their responses to the last 4 comics. So it gets small data set, so it's not as fun to play around with sometimes. So here we are creating a variable called HTML, and it's basically the contents of this xkcd page, which I'm not going to show you yet because I don't want to spoil what we're pulling down. And then I just used a print function here to print out the information there. So you can see this is what our page looks like. urllib has a URL retrieve function to retrieve resources, so that's what we did. Or that's what we're going to do basic web scraping. Here we're going to look at the robots file to see if there's things we're not supposed to pull, and he just doesn't want us in his personal directory. So we're fine with that. We can then use urllib with URL retrieve to go through and pull information out. So what I am pulling out in here is basically I sat down and looked through the code and found the hot link for embedding. So xkcd gives you a hot link all the time for their comic if you want to embed it in something. So we're going to pull down that file. We're going to pull down basically the comic. And if you run that cell, and then double click here, the little broken icon was because the file didn't exist on my computer before now. Now we can rerun that markdown cell and we get the xkcd guide on APIs. And then here you go. If you do things right, it can take people a while to realize that your API documentation is just instructions for how to look at your website, which it basically is, but hey. So there we treated the HTML as an unstructured string and pulled things back from it because we knew where we were looking and we went in manually and listed it. beautifulsoup will let us actually start looking at this stuff as structured documents. And it will parse through HTML and XML. So if we take a look here, I've given you a sample page of quotes, and we're going to scrape those quotes. Or are we? We're going to check the robot file first to make sure we can. It doesn't print out really nicely there, but if you do look at the robots file, the page that we are scraping is not excluded by it. So we're going to import our package beautifulsoup. We are going to set up a URL for the website that we want to scrape. We are going to pull that down with urllib, and then we are going to use beautifulsoup to create a variable called soup. Everybody see what's going on there? Beautiful Soup also has a function called prettify, so we are going to print that out in a prettified manner so we can read it a little bit easier. So this is basically what Beautiful Soup is doing. It's taking in the document, and then it's creating a structure that we can address using the library. You can see here we have different content we can look at. We can look at links. It's going to go on for a little while. But you can start seeing here, we start seeing the quotes and the person the quote is attributed to, and that's the data we want to go through and pull out. And I'll keep scrolling and scrolling. All right. So then we can access the information through tags in the document. So soup.title. There is an element in our document, it's called title. When we tell it we want the title element from soup, it's going to print that out. Some of these tags, like title, have names, and some of them have attributes. Unfortunately, I don't think title has an attribute. So nothing came back there. But there is a string. So it basically, our title is this with the HTML tag. When we say title.string, we get the string within our title tags. We can use these different attributes to navigate through our document. So we have our document head, and we have our document body. Within our body, we can see the quotes. So let's highlight that here. Okay, so when we see our heading tag there, that corresponds to this heading that we're seeing here on our webpage. So we can address things we can look for that heading tag. And then again, if we just want the data within the tag, we can do text here instead of string. Sometimes it's string, sometimes it's text. It depends on the attribute or the tag that we're looking through. So Beautiful Soup will also let us navigate through the structure, and I really encourage you, if you're going to be using this package, to go through their tutorial because they have a really good example set up on how to navigate. And there's a lot of things you can do navigation-wise in Beautiful Soup. So if we look here, if we look at the parent of the body, this is the information that we get. If we look at the parent of the head, that's the same thing, isn't it? So we can see here we are getting the same thing. So that means actually head and body are siblings of one another in the Beautiful Soup terminology. So if we look at head's sibling, we get our body. And that's the basics of navigating through. So there's sibling attributes, there's parents, there's children, and I think this document, the quotes website doesn't have a child set up, so we didn't do that. So if we look at our heading 2 tag again, and we look at its next sibling, we can see we get our first quote. So the way this website is set up and how Beautiful Soup has parsed it in its document structure is you have a heading, and then each of these quotes and these numbered quotes here are a sibling of it. So you can look at next sibling, and that's not something we want. But then next sibling of heading 2 is quote number 2. That can be a little cumbersome to go through, chaining all those next siblings. So Beautiful Soup also gives us some search functionality. If we do a find A, it's going to give us the first A tag. If we do a find all A, it will give us all of the A tags in our document, which can be useful if you want to parse out all your URLs. So here we go. This is the URL, the href from each of our A tags in our page. So you can see how this can be kind of hard to teach somebody to do because it's going to be different on each page you encounter. But at the same time, there's some basic functionality that we can go through. So I'm not spending too much time on this because I really encourage you to just kind of dig into a page that you want to look at and start navigating through it. Pull it into Beautiful Soup, navigate through the tags, and see what you come up with. So we can, if you're also CSS proficient, there's a couple different ways that we can pull out information using CSS. So here we have a class called WP quote page that we can pull using the find all, or we can use the .select attribute or function here, which is going to allow us to pull things out for CSS selectors. So these two are mostly doing the same thing. We're getting a little less information in the div part because we're going to the end of the div, to the close of the div tag. But if you do WP quote page, you're getting all of the information that's there. So if we want to use that, we can then use that to start pulling out our quotes. So if we do, basically we're setting this up to use the CSS selector, and for each quote in there, in this loop, quote is not something specific. It could be item, it could be for each dog in WP quote page. That's just the word we're going to use here to start addressing it. We are going to find the child and render the contents, and then for the author, we're going to find the text is the first child and the author is the second child for each of these items. And that's something you kind of work through playing around with Beautiful Soup. So if we go through here, that's going to start to print. We have a print command there that's going to print them out. So let's see if I can illustrate that a little bit better. We have our quote page. It's going to read each of these things as a item. So it's going to, let's go to, sorry, this is hard to scroll back and forth between. So it's going to find the first, find child 0 and render its contents, and find child 1 and render its contents. So if we look at a quote, let's look at the last one down here. Second to last one. So it's taking this item as quote page, or it took this whole section as quote page. So each of these div tags is our quote. So for quote, we are taking find children 0. So the first child is this part. And then we are going to do find child 1, which is this part. And we're calling that text and author, and then we're just printing it out. I'm not an HTML, CSS expert. I really haven't built web pages. I've broken a lot of WordPress CSS, and I really haven't sat down and wrote a page purely in HTML since the GeoCities days, so I will date myself with that one. But if you sit here and play with it and have the patience to pick through it, you can start pulling this stuff out. If you're a web developer, this is probably second nature to you on what things you want to start pulling out. But here, so we've pulled this out. It's not the neatest thing in the world. We have a little bit of extraneous quoting in there. We can start using string functions to clean that up. So basically what I encourage you to do is go through and build a website, or go through a website that you want to play with. Jupyter's a great environment to try to play with this stuff in because you can see your results, or the IDE of your choice. And then you can start playing around with how these work. I have given you some resources here on scraping tutorials, and I've also created one more notebook that we'll go through quickly. And I've given you some suggestions here of things that might be easy to start scraping. So you can look at Wikipedia has a lot of lists. Lists from web pages are easy things to start scraping. So you can go through and look there. So let's take a look at this. Oops, that's not what I wanted. Does anybody have some questions on that? I'm going to go step through scraping a web page. So it might be easier to see that, and then we can ask questions. So as I said, I was sitting on my couch last week trying to figure out how I was going to teach this a little more in depth than the overviews I tend to give in workshops. And I got an email from Drink Up New York because they have really great booze selection, really good to order, good prices. So I'm like, well, maybe I can scrape their site while I'm thinking about this so I can think more about my process. So I just basically created that as a notebook. I did check the robots.txt file. There's a link to it there. The pages I wanted to scrape were not in the disallow section. All right, so And here we go again. I'm using requests this time, but I could have just as easily used urllib. I just chose to use text this time around. So if you take a look at their site, they have a lot of menus here that you can navigate through to get to places. So we're going to go to Scotch because Scotch is the best. So if you go to their whiskey section, you can see they break it out by different types of whiskeys. All right, so I'm not going to navigate to it through there because their navigation structure can be a little bit of a pain depending on your screen resolution. But this is the Scotch page, essentially. So if you go through those menus to the Scotch section, you get this URL, you get a page with 12 bottles of Scotch, and they have 6 pages. And you can see they have their sale price and their regular price, and as we will also see when we parse the data, there's a third price we can get. So what I did to simplify the scraping process is when I was here, I changed this to 120 per page so I could get everything on one page, and I use this as my URL for scraping. So here you can see after the 77.htm, we have a little more information here to go through. So we're going to pull that in with requests. It's taking a minute. And then, if you're new to Jupyter Notebooks too, you can see that after you execute a cell, a number gets here. While it's the asterisk, that means it's running. So I was just waiting for that asterisk to change to a number. Here, I'm just going to check what's going on. So I'm saying here that if my status code is 200, print out the information that you pulled back. And if it's not 200, print out the status code. So what I'm telling my code here to do is if everything's okay, show me what you pulled back. If it's not okay, tell me why it's not okay, so I can look at the status code and figure out what to do with it. So this is what our page looks like. Let's pull it into beautifulsoup and do a printify on it so we can print it out. If you have ambitions for web crawling, this is probably a good site to hit since we don't see anything saying we can't, and they have that great menu structure, which you'll start seeing here in all these links. So let's start looking at some of the data. So head is a tag we have. I wouldn't expect my data to live in the head of a page unless somebody was writing funny pages. So here we can see we have different metadata. So we have the title, we have the information here, which corresponds to the information we are seeing up here in our page. And fine. All right, nothing too exciting there. So soup.body. This is where we're going to start seeing all the links in that menu structure they built out. So this is a good thing to crawl because you're going to hit a lot of links off of one page and you can build out their network. So if we do this, this is all the links. That's just on this first page. This page is all we're looking at, and this is all the links that you can get off of it. So you can basically build a network of their entire website from one page, the way everything's linked together. And then when I was looking at the body, I noticed there were tables in here after we got down underneath all the links for the navigation structure. Let's see where, okay, here we go. And then we start hitting tables of data. Oops, I don't want to do that. We hit tables. So I'm going to start looking at the tables. So there's a bunch of information there. We can look at the length of the find all results. So there's 12 tables in my page. So chances are all the Scotch data resides in one of them. So let's take a look at table one, the first table that we get. Nope. We don't have the whiskey data there. Let's take a look at the second one. Nope, that's a shorter table. It's not the information we're looking for either, though. But then when we look at the third table in the list of tables that returns, we can start seeing the information about the Scotch. That's sort information that they have, results per page. Okay. here we go. We start seeing information about the scotches in here. So now the question is, how do we get to them? Well, it's a table, so I'm like, okay, maybe it's in a row. Nope. But then if we when I was looking here, we see we have these CSS selectors, we have the products. So that seems like a good thing to check. And if we look at what Beautiful Soup, so Beautiful Soup is giving us a list when we're using a selector. The length of this list is, oh, they got new scotch. Sorry, I just ran through this like a day ago, and it was 65 items, and now it's 66, so I'm going to have to build my list out. So if we go back and we look here, I think it gave us the initial results someplace, but basically that makes sense with what the page is that we're seeing. So we can start parsing through those products. So if we look at product 0, the 0th item in our list, we can see that it's basically a listing. So we have our scotch name, we have the link to the page for that product on their website, and then we have pricing information. So there's a regular price in here, there's an R price, and there's a sale price. So our price is the price they sell it for, the regular price is what they say the average everybody else is selling it for, and then we have the price for it on sale. So that means we can start parsing this information out. So I took a look at the vProduct CSS selector, and here we go. That's one product on their table. One product on their page. So we can define scotch as being the first item returned by the CSS selector here. And then we can start addressing, using the tags that Beautiful Soup gives us to get information. So I played around with some of those to see if I could find where that information is again. That didn't work, so let's try this other selector. And we start seeing, oops, haha. See, I do this even when I'm coding for myself and trying out things. I tried to get vProduct title, which is a selector. When we use selectors, we're getting lists back, so there is not text. We need to tell it the text of which item that we want. So there you go. We can start pulling things out. We can do similar things with the different product selectors. We can just pull out the text, and there we have all the prices of our scotch. And then if we want to pull out the link, we can try that too. And if we go here, we can see this is the product page for one of the whiskeys in the link. And then we can start playing around with cleaning up our data. We can use our string items to pull things out and clean data up. So you can either pull it as it is from the page and scrape it into something and clean it later. You can clean it while you're scraping. It all depends on what you're working on and what you're doing. So what the rest of this notebook walks through is pulling the different items out of that page and getting some text that's nice that we can throw in a data frame. So here we go. We're going to pull in pandas to make our data frame. We're going to start with I equals 0. We're going to define some columns for our data frame and create an empty data frame. And then while our I counter is less than the length of our table, since that's the number of products we have, we are going to create an item called new scotch, which is the name of the scotch, the link to its page, and the 3 different prices we saw. And we're going to append that to the data frame, increase our counter by 1, and go until we have everything. i.e., we're making Nicole's Christmas list. So then we can just take a look at our data frame, and there we go. So that is what you can do messing around with Beautiful Soup and sitting down and just going. I mean, there's really no easy way to do this. You just kind of have to go through the page and see what's there and play around with your selectors and pull out your text and see what you have to get what you want. So then now I fully expect you to go sit down and do this with a page on your own. You have all the code here for Drink Up New York, and you saw how many pages they have. So if you have a favorite alcohol of choice, you could make a list there. If you're interested in working with Scrapey, I do recommend starting with their tutorial. Their tutorial is pretty good. They have a page set up for you to scrape. They show you how to do it. But I've also done a sample here in this, under the scraping, there's a Scrapey directory, and there is a spider created with Scrapey to go out and pull some of that information that we just went through off of Drink Up New York. So who has scraping questions that I probably might not be able to answer completely, but we'll see what we can do. Does everybody feel like they have enough information now to go sit down and do this later? Okay. Do you want to ask any questions about the libraries, the process, the ethics? Yes. Does the Beautiful Soup module have authentication? I'm not sure. I have not scraped pages that did that, but if you do Google scraping pages with authentication with Python, I know there's resources out there. I'm not sure if I linked in any of them, but there are ways to get that information into your code so you can log into a page basically and scrape it. Anybody else? Okay, so Will is going to come up and give us a little information about baleen, so you can start thinking about ways that you might want to operationalize some of this type of stuff. So let's pull these slides over. Oh, so to summarize, scraping's kind of hard. It's not, there's like no one recipe I can give you to do everything. Make sure you take a look at your robots vitals, think about the ethics of what you're doing, and go get some good data. So here we go. I'm going to switch this
All right. Whoa. Okay. Here we go. So baleen, space whale. So DDL, to give you a little context on this whole thing, has a lot of people that are very interested in machine learning and specifically researching natural language processing. If you're familiar with that problem space at all, one of the biggest things you run into is just having enough data to work with. So there was it called corpuses, corpi, corpa, rubba, I don't know, it's Latin, plural is always hard. But building up big chunks of text to work on was really a big problem a lot of the people in our group were facing. So we built this thing called Baleen, which is essentially a giant internet data aggregator. It uses RSS feeds. Web scraping tends to be a little bit brittle. As soon as somebody changes, one CSS class on their page, you might not be able to scrape it anymore. So we stuck to just RSS, which is a little more well formatted and has some specifications around it. So we went out to a thing called Feedly, which is a website service that will do, RSS aggregation for you. And they have a big list of RSS feeds, like hundreds and thousands of these suckers. So we stole their list, we procured their list of RSS feeds, and we wrote a Python application that takes this big list, goes out, fetches every list, and so every RSS feed has, a ton of like posts or websites listed inside it. And then we retrieve that data, and we end up with web pages. Just HTML for web pages. And by doing this, we can go through the web, collect tons and tons of written data, blog posts, news articles and whatnot, in different categories, which is kind of a fun part about what Feedly provided us. They had, like entertainment, news and blogs, technology, yada, yada, yada. And we can build out this giant corpus of information that's categorized roughly by what topic it is. And then we can use that to do all the natural language processing stuff we want to do. So Baleen, like I said, it's just a Python application. We added a nice little Flask Django like web app in front of it just for like status and error reporting types of things. And in the back end, it's storing everything in MongoDB. It's actually pretty small, self-contained, and this is just running on an Amazon EC2 instance, and it periodically, once an hour, will go out, run through the entire list of feeds, look for changes, because obviously here, if we're dealing with thousands of feeds with hundreds of thousands of posts potentially, we can't just download everything every time we run this. So there is a stateful component. We look for new feeds or changes to the feeds or new posts within feeds, and then go out and do the actual fetch. When we find updates, we will cram them in Mongo, and then we've got the storage there. So there are a few challenges with this. Web data is ever-changing and can be a little bit weird. Like RSS feeds don't always have just text. For a while, we were accidentally subscribed to an RSS feed that was giving us full MP3 files. So that was interesting. You can imagine what happens when you try to do text processing on binary MP3 data. It doesn't work so well, so we exploded. So we had to go in and like look for media tags and things of that nature, so we didn't download them and try to store them as text. And then there's always the problem of disk space. We ran out of disk space in our EC2 instance one time because at this point we've got 60 gigabytes of Mongo database sitting around. And we were running on like a micro something, so it didn't have nearly enough space. So you run into little things like that. But the whole goal of this project was really to make data collection easy for NLP research. But beyond that, we wanted to make it easy for everybody. So the project, it's out on our GitHub. You can actually use this if you want. It's got pretty easy setup instructions, so you can just get a little EC2 instance with Amazon, spin it up, start collecting data. And we're actually looking for help with this. So if you're familiar with the sprints that happen at the end of PyCon, we're going to be around. We're looking for people that are interested in this sort of thing. Specifically, we've got a lot of things around like packaging and distribution. We'd love to make it as easy as, apt-get install Baleen, and then boom, done. Baleen's up and running on your box. So if you have any interest in that, definitely come see us. Otherwise, any questions on Baleen? Conceptually, it's pretty easy. You just take an RSS feed, save it. Yes?
Can you give an example of how you used it for NLP research?
Can we? I will switch slides.
So the question was, can you give us an example of how you used it for NLP research? Well, yes. We're actually giving talks on this. So the building a gigaword corpus, lessons on data ingestion, management, and processing for NLP. That's happening on Friday, and that's Rebecca? Yep. So come to that talk. Can you hear how we learned all about it? We're also doing a poster on Baleen on Sunday. So if you want to come and see like architectural diagrams, you can come and do that as well. Okay, cool. Baleen.
Thanks, Will. So see, you start making a top 10 list with your RSS feeds, and then you're building gigaword corpuses. So that basically wraps up our tutorial. Lunch starts in about 7 minutes. As I mentioned, we're from District Data Labs. We're going to have more people here through the week, so these are the talks we're giving, the posters that we're going to have, and then the development sprints. So on the GitHub repo, if you look at the top, there's a web link there. That will get you to the slides, so anything that's been linked in the slides you can go to from here. So if you want to figure out what a sprint is, there it is, and then we have the different items linked here. So hopefully we will see you throughout the week. Thank you very much for your time. Please let me know if there's any questions I can answer for you. And if you have any additional questions about getting things like content environment set up, let me know. I'll make a list of stuff, and I will add to the GitHub repo for you guys so you can go pull those down later. Okay, thank you.